Hello everyone, thank you very much for being here. So our presentation will be divided into parts. I work in malware and that kind of thing. This is the contents of my presentation. The idea was to do something with hardware, and I just wanted to have a board that you could plug into a device, a corporate device or challenging device, an isolated computer with no internet connection, so what you can exfiltrate information even if it doesn't have any internet connection. And I also want that to be valid for one equipment, for one specific equipment. And that was the idea behind it. So everything that shows on the screen is what I tried out. I bought the USB controller. Can be programmed as you wish. I can tell Windows, I am mass storage, I'm a keyboard, all this. Then I also introduce a radio module, so that is exfiltrate through 333, and I want it to be a multi-layer attack. So you just plug in the board on the computer and then the program gets information about the serial number of the hard drive, and then it downloads that information to the USB. And then when the microcontroller that I programmed detects the writing and says, is this the machine that I want to attack? Then if so, the USB is rebooted, then the current is switched off. This is like if you have replugged it, and then in that, when booting, it will introduce malware, it will inject malware. So you may go and say, you may program, if the name of the equipment is Telefonica, whatever, please attack those ones. So that was the idea. It could do several things. And then I also thought, okay, I want to plug it in, and I want to simulate that the computer is blocked, so that it asks you for the login. So you enter the username and the password, and then it exfiltrates information through the radio device. It allows you to do whatever you want it to do. The only limit is your imagination. At the end of the day, we're talking about an 8-bit processor, so the microcontroller of 8 bits, it's limited. That's the limit of it. And then when it came through exfiltration information through the radio, imagine that we are talking about bunker, place that is shielded, and if information cannot be taken out, and I said, okay, I will introduce an SD, that everything that is stolen goes to the SD. And because the malware is being run on Linux or Windows, so that the malware is encrypted in SD. And then I said, well, if I leave it as a file, someone, when that's forensic, will find out these strange files. And then I said, I want the microcontroller to capture the writing of the malware whenever it wants to exfiltrate part of the content of a file, so that it detects a special type of writing different from that of Windows, and then it keeps it within the SD card but in a hidden place that cannot be accessed to. So that is to say, the microcontroller says, this file isn't being written by the malware. Well, that's because it wants to steal that information. Then I hide it on the SD in an area which is only a writing area that you cannot really access to when reading the microcontroller. Well, if you open the device and take out the SD and do forensic, you will find it, but it will be encrypted in a sector which is not even in the file system, and it is encrypted, so you don't really know what it is about. And then I also wanted to self-delete itself, so the malware, when it goes from the microcontroller to the victim attacked equipment, it is deleted. The malware stays on the machine. By the time the information is fully stolen, then it is eliminated. So the time window for the researcher to catch me would be before the attack, and I can program it and say, if this is kind of tapped in 10 times, then you delete it. So therefore, no malware is left. So that was the idea. I just wanted to do all that through the USB. I am basing that on the LUFA, which is a stack from USB, which is often used in AVR of 8 bits. I modified it, I changed it for it to support SD card because the original one was for data flash only. And then I also took a project from Matthew Sonnet, another controller that did the same thing for SD card. I adapted it for this microcontroller. I changed a couple of things. And then the code of Matthew Sonnet only worked with old HD or HCH modems. Everything was static. Then I got the FS for 8 bits for when you want an embedded system. You use the when you want to do things with the FAT system, you use that library that has been highly tested. Then I took within the SD, I put everything together, and I say it doesn't really matter whether the SD is an old one or the new one, SDH cards 16 or 32 gigas. It is a code highly tested and adapted everything for the CPU, and that was it. I wanted to disturb those who do the forensics, whether it is Lorenzo or whoever. How can I do that? Well, every time the USB is plugged in, it randomizes the vendor ID, the product ID, and also I want the USB descriptors to be dynamic. And say, now I'm a keyboard, now I'm mass storage. I am both of them. I'm nothing now. So that you have that freedom to program your attack. And then the hard drive serial at the 0 sector of the FAT, I tamper the value. So it is like inserting a new USB. So if I finish the attack and I eject the USB, someone will go and say, well, this is not the USB that has been used. I don't know whether I have made myself clear because I told you very many things, but I hope so. So the emission transmission is through the radio. I did a POC with Arduino, with ESP, and then some text messages through GSM and GPRS. So this is the board that is manufactured in China, has been assembled here in Spain, and I said, well, this is logged in, and then it transmits data through air, and I just didn't want to be caught and to end up in prison. So I have this box, I can open it and then to insert the radio module. If you do not, well, if you have a public cable, though this image right on top is a puncher, then you just, this cable is back, and then you get like power. So you have to be very careful. Don't do that, you could die. And then I took some photographs at home so that you see like one of those electricity cabinets. You can put in a whole Arduino. Then you just put in the exfiltration mode, and then, or you open a street lamp and then you just put it in there, and that's it. So you have an exfiltration mode that sends you text messages or WhatsApp messages. You just decide how you want to receive it, either through Wi-Fi or you just get some antenna, you hire a home next to your home, and then you get information, and then you leave. And that was the idea. This is a proof of concept. I brought it with me. This is the emitter, this is the receiver, and then the emitter. This is like kind of crazy. I reduced it down to this board, and you can always make it smaller if you so wish. It could be further reduced. Okay. So that's the idea. We move on to the demo now. So we have Arduino. Arduino switches on and off the USB. There are several advantages to that. When this logs on and gets the name of the hard drive or the name of the victim equipment, I cannot really tell to Windows, look, instead of reading this file, there is a malware instead, because Windows caches many things. If that sector has been read, it will not be read again up until few things will happen. Then I started to test it, and I say, oh, no, I just don't want that. So it will change it for me. And I said, okay, I will introduce a chip that will be able to switch on and off the USB, like if it were physical logging in, and then I will just take advantage of that, and I will inject the malware. And if there is something strange, I just don't have to identify it. I just wanted to work in phase 1 or 2, which will be switching on and off. So I start off from a well-known status. So I don't have to do anything strange, so to speak, and then everything goes faster. Okay, I'll switch it on, okay, so that you make sense of it. So this is the Arduino terminal. I have the debug, the drive tells Arduino everything that's been done. So you are just what you did social engineering, or you just left some USB around in the company, or you did something with the cleaning personnel and say, well, okay, I give you this amount of money if you plug in this USB for me. Then, once the plugging is the USB is in, let us see what happens in debugging, okay? This does not happen or does not exist at the victim machine. So the hard drive reboots, and then the file system is loaded, and then, oh, sorry, you cannot really see it. I thought that you could see it as I was speaking. Okay, give me a sec. Okay, I will exit. Debug. I will reconnect. Oh, log in again. So I am starting the hard drive with the SD card, and we have the USB that has been detected. How is the malware run? I just don't want any interaction from the user. So this board is telling Windows, look, I'm a mass storage, but I'm also a keyboard. So, and then this is the keyboard. This is very slow now, but in a real attack, this will go faster so that the user cannot see it. And because I don't know when Windows detected it, I do brute force. So F colon la la la. And then at the end of the day, I press enter when it fails. That's it. Phase 1 achieved. Then it took the name of the machine and has just dumped it into USB, and I said, look, I'm in the victim machine, and the microcontroller said this is the machine that I want to attack. Arduino switches off the current and then switches on back again, and now we are in phase 1. This file tries to boost the same reboot the same file again, but this time we'll not take information from the same place. This time we will have the actual malware doing the attack. So it is relogging, and it is rebooting the same file. I don't know whether you can see it. It's starting the same file, G1, and all the time it's trying to run itself all the time, but this time we do not have the same program, but a different program, and it has been encrypted. So therefore, well, this is a bit slow because of the 8 bits controller. So it means that the card is slower than in SD native interface. So the f.exe has been started, but this time it says stage 2. That is to say, it has rebooted. This is the victim machine, and we have the actual malware that will steal information. And you have to come to get to this point. So this is, well, I'm asking it to open a calculator, and the calculator will steal a file which is in column. It is, I don't know, maybe a certificate or whatever that you want to steal. It opens that for you, and as it says to microcontroller, I've been run, I am the actual malware, and I'm going to steal information. And then the microcontroller detects that writing, and then I physically restart the connection, and then the microcontroller is already stealing all the stages of the malware from the inside. So in this stage, if someone gets the malware, there is no stage 1 or stage 2, no ciphered and encrypted and unencrypted, so no malware inside, no nothing. But the malware will write, especially inside, that will be exfiltrated through the radio, and so the first block has already been exfiltrated, and it will exfiltrate the whole information. You will get the top secret file. I don't know whether this is going well or not. Give me a sec. Is anyone doing implementing jamming or anything? I hope not. So detect writing, sends it through radio. Well, if I cannot fix it, I will restart the attack. I could boost it. You are not doing anything strange here. And you? Okay, reboot the attack. So this is very good when it comes to, well, doing this type of development, okay? Give me a sec. No problem, this is expected. I have this button, so during the development, okay, you tell it, okay, let us start off from stage 0. Okay, let us redo everything again. This is okay for developing the attacks. My mistake, okay, now. It deactivates the MOSFET. So this also allows you to do other things. For instance, you could enter other switch, and I say I want a microcontroller doing that, but at the time the attack is finished, okay, I want to switch to another one. Stage 0, and then it will reboot. So when I was programming that, and I say I'm going to emit through the radio, sometimes the file was kind of cut. And then I said, okay, I will enter delay, but I didn't know what. I had to do a serial protocol sending a packet 10 times. So this is not a transceiver. So it only emits through the radio, again, stage 1, stage 2. So the idea behind it is that it receives the packet, and when it receives 10 times the packet, so once it receives the packet, it generates a final file. That was on the problems that I had to make up a protocol and a structure for a good radio transmission. And as I said, the packet is sent out 10 times. This also makes the attack slower. You can only exfiltrate small things. Perhaps in the future I will just introduce a 2 megahertz module for larger attacks. We are already on stage 2. Okay, mega. I will check that nothing is unplugged. So imagine I couldn't use my dining table for a week. So my girlfriend is fed up of me. Okay, now exfiltration stage, everything is rebooted. So stage 1, stage 2, and now the microcontroller is told to steal the malware. So this is only deleted if there is power. If a researcher, so if a researcher is there, Okay, and I said, well, as long as there is power, then or voltage, the malware deletes itself. Okay, see if it works now. Oh, it is not working. Everything is all right. So it was working before. Packets were being received. So the thing is that if one of these elements is kind of unplugged or not fully plugged in, so I don't have board to exfiltrate because I wanted to use Raspberry Pi. Okay. Haha, I know what's going wrong. Now I know. At home, I had a different laptop on my table as a receiving equipment. Okay, I configured it to see the output. Okay, so, yeah, packets were being received here. Okay, I go ahead with my explanation as packets are being received. So this is a shopping list of everything that you would need to set up this prototype. If you want, you need this USB board, the programmer, this resistance, these coils, these calipers, and then the ACME board. I didn't know how to connect or log in SD. No one knew what to do because actually there are some holes, but I didn't know how I could connect the SD. And I said, okay, I'll use LED, and then I will. And then I said, okay, I'll do it like that for my prototype. This is the list of the names that you find on AliExpress. They do not really make sense because it's very strange language, English language. And this is the USB switch. This is the most difficult thing. You need a pad, use this padding, and then you implement an analogic switch. The board, as I say, can be switched off from power, but you can also switch off the data lines only. So if you want to implement an attack and saying, okay, I'll switch off the data links, the board is not reboost. You have two options. You switch off the data lines, but because I want to start from scratch, I just unplug it and then I replug it. But I could disconnect or unplug the data lines only. So this is my dining table, this is the exfiltration module, and this is the board that I manufactured. I will put it on sale. I don't know how the price that I would put it, and this is a euro coin. So the size of it could be reduced even further. And now I have a button there for Wi-Fi. Oh, apologies for that. That's SP. I didn't do it on purpose. I know that. "30 minutes left? Okay, I'm finishing." So there is a Wi-Fi, and it also filters through the messages. So this, I just log into the Wi-Fi. So there is a problem here with voltages with conversion that may not work. I have kind of problems with radio things here. Okay, so we have the IP. This is when we want to exfiltrate through Wi-Fi. For instance, we may have had a neighboring building. This is stolen information. We have a website where we get information from. The next step, if we don't want this, I have set up this module, close SP, send messages. And okay, my mobile phone is not there, seeing it. So this is this module. This module, through text message or the internet or whatever, sending to me everything that it's being exfiltrated. This is a proof of concept with Arduino. You can do it your own style. This is my phone number. Well, no big issue. For some reason, the radio transmission is not going well, and that is the idea about it.
And I'll show you how it works because maybe it has disconnected. And now, I want you to be very brief because I want to finish with this. We're going to see how the story works. So what happened here? Okay. Very briefly, the SD that you have, well, it has two things. It has a mass storage of 2 GB, and it has another one. The folders coming from the different stages are after the 2 folder LSD systems. Windows doesn't see them because Windows, when it asks what's your capacity, it says 2 GB, and the controller puts these 2 GB. Of course, the SD has to be bigger, and it was like if it was just 2 GB, and the encoded folders come after. And depending on the attacking stage, maybe if I'm just the first stage, well, I can give you either the first or the second, so the microcontroller puts this into the FAD. And after all the folders that you want to put in a row, if you have a very sophisticated attack that are all encoded, of course, we have a defiltration area. The SD can be used from there. The capacity that we've included, so that it can filter. It can filter everything your malware writes down in a special way. It will be registered by your controller, and it puts everything down. So if it's at an isolated bunker, if you paid somebody to plug in the USB disk, you can tell him, well, bring it back 10 days ago, 10 days later. 10 days later. There's an asymmetric keyword. You're the only one that can decode it, and that's it. I don't want to get into further detail because it's a great mess, but well, this is the idea. I won't do this because I don't have time. I've created a suite to do all this because it's a great mess. So the suite that I've created, it creates a folder system. Another one, it generates an image with everything. Apart from that, it adds up the malware, it encodes it, and you have to say, well, I want to put this malware, this, and that. You encode them, you create an image, you upload it in an SD card, you put that SD card in the flash disk, and that's it. So do you understand that more or less? Because you need to create a very complex structure. Everything is ready for you to create the malware, and it creates everything. Everything that I've just shown you. If you're looking for something special, more stages, or decode it in another way, you can try to do it on your own. But the idea is that I have a suite to create this in an easy way. How long to it? Okay. How are we doing with time? Okay, So I would like you to tell you how we program all this, how the microcontroller works, and so on and so forth. So I'm going to reset all this, not to screw it up. And well, something that I wanted to show you is this, before disconnecting it. So we're going to open the device manager option, and the point of the randomization, well, you can find the mass storage that is being detected. Here we can find some details. And we have the bit description, we have the bit that is 6969 and 9696. And we are here with the strings of everything that is detected, boom, boom, boom. And here you can find that the Celeris drag. This is the mass storage keyboard, review whatever. And we keep on moving, evil mass storage in keyboard. And here we have the mass storage. The keyboard that is detected is here. As you can see, we have another keyboard. One of them is the one that tells Windows that this is 6969. And here, this is the keyboard that is detected. Take into account that this is not a hub, okay? This is not the typical hub you have at home where you plug in a flash disk and that's it. So what does this mean? Microcontroller says, well, I'm in USB and I'm two things at the same time. When you have a webcam, what does a webcam have? Mic and images, and it doesn't have a hub inside. It doesn't have a mic with a webcam. It is both things, and you need to program it so that it's possible. Okay, so that you have the endpoints, etc. I won't explain all this right now because it's really difficult. So that's the idea. And you've seen that of 6969 when now I end up by filtering the blocks. Okay. So restart, perfect. So when this is over, when the attack is over, Windows, it will tell Windows, hey, I'm just mass storage, I'm not a keyboard anymore, and it will update everything. So we'll see as soon as it finishes. And if you want to program all this at the microcontroller side to play with the microcontrollers, etc., the books that I've read are these two. From Janet Axelsson, well, that name, and she's great. The books are really good. They are quite dense, they're quite difficult to read, they are really boring. And the point is that it's focused on PIC, and this is AVR, so you have the code, but you need to adapt it. If you have any doubt, if you have any question, I can give you some references. I will upload some example codes to GitHub. I've done a couple of pull requests to put this at the official folder. So here you have the 90 USB case. This is the board that I've bought for the prototype. And you have the data sheet of the microcontroller that I'm using. AUR Freaks, that is the forum. There's a great community there. The FAT, that is the CHAN. And the UFA, that is the USB stack that I'm using. These are the references. So, in terms of the to-do list, well, there are overflows, there are leaks. It's a crap code. So I want it to work, and that's it. So it's just a sample. We need to improve the code, and the FAT-FS performance has to be improved. The ISR should be faster, and now we have this attack that I want to do. The typical thing of, well, it simulates that the computer is blocked, you generate the password, and I want to put some examples showing everything that can be done, not only this attack. Okay, so we want to document some things. There's nothing documented, and we want to put some examples for OS X and Linux because, well, you implement that mass storage protocol and it works. Now it only supports the keyboard in English. So what I've thought is that instead of saying, well, the keyboard is either in English or Spanish, I'm going to create a story that includes everything possible, to put that 2 points in English and Spanish, and when there's an attack, it includes all the combinations, and I'm sure that some combination will work. That's much simpler, because when you have C2 points, A.exe, until you take that mass storage. The point that we have here, the problem that we have here is that those 2 points, depending on how our keyboard works in terms of language, they don't work. So I want to make any language working. If you want to attack any Russian company, I want it to work. So now it's only able to filter a folder because the protocol is crap, as I've just told you. So this is the problem. I want to do it multi-folder, and this is much more complex, but I didn't have time to do it. And I want to choose filtrations. I mean, I want to have these folders. I want to store them by radio, and you in the malware can set what you want to steal and how. Now everything goes through radio and SD, okay? Because I want to show both functionalities. So the future, what do I want to do in the future? Next version, I wanted to use an ARM Cortex M4 that has nothing to do with an 8-bit controller. It's much more difficult. 180 with 32 bits, and I want to include an RF transceiver. I mean, this device should be able to receive, because I want that the defiltration module says, hey, I'm not getting the packet. So until it doesn't say, I have the packet, we follow with the same packet, and the same block, sorry. So we want to program out what this folder has to be received. So I'm going to send it until we get it, okay? So I want to include a transceiver, and maybe it will be based on these chips that really work. It has nothing to do with AVR, and that's it. So it has a native interface. So this has already been done, but I've made some tests, and I get 15 megabytes of reading and writing, and I can optimize it. And they have cryptographic acceleration. The only thing that I've included here as an encoding is a soar with a byte, because otherwise it would be too slow. So it's useful for poke and to do some things that are not important, but I want to include some chip with cryptographic acceleration. So if we want to do more serious things that is more difficult to do the forensic devices, and that it's not penalized in terms of processing, because you just think there's one block, I need to wait for the SD to give it to me, now I have to decode it, my controller has to put it in the end pin of USB, so everything should be as quick as possible, because otherwise it could be a 1K, it could seem as a 1K USB. And the good thing of this chip is that it's the one that is being used by Kenzie for people that want to program in C. Hey, it's done now. So the attack is over, the malware has been closed, and now it will be a mass storage. Now it will be just a mass storage, it won't be keyboard anymore. So now it's activating the MOSFET, there's current again to the USB, I have all the readings, and it's just a mass storage here. We only have one keyboard, this is the one of my machine, it will be 6969. I'll put it here so that you can trust me. And now it's a regular pen drive, it's not a keyboard anymore, and we're going to see the mass storage right now. We're going to see the serial numbers, how they're called, etc. So now the bit is 8686, and we have 6868. It was 6969 and 1996. And now what it tells Windows is that this is called, what was the name here? What name did I put here? Now it's called Vendedor Drex, and now it's just Evil Mass. It's not mass storage plus keyboard. I don't know if you remember that it was called differently. I can change absolutely everything. I have full control of what the USB is doing. It's not a rubber bag. I'm programming my microcontroller. And there's a story. So here we have this pen drive, and we can format it. We can delete it. It will be slow, but it is SP, so you can format it. Something very important when we are at stage 1, well, there are things inside. If we delete the folders, I tell Windows, okay, I've deleted it, but I never ruin the integrity until the attack is over. When somebody else reads that block, Windows will perform all the logic. So I formatted it. You see that it has another name. It's empty. Well, the story. The important thing here is that it's a pen drive that looks as if it was real. And when you want to ruin the integrity before the attack, the new connection, everything is as it was at the beginning. So you reconnect it, and it is as it had to be for the attack to take place, because I never end up with the malware or the FAT. I know how to rebuild the FAT if it is touched. So that is the idea. And what else? At the same time, you can generate some mass storages at the same SD. What can you do with that? It's for an attack. You can say, well, give them a pen drive and I make them think that it's a pen drive. So you can create a logic that says when I have 5 PDFs or I have 5 documents with X number of files, I will change to other mass storage. And what can you do with that? You can steal what they've been doing with that pen drive. So you say this company, well, some documents are delivered by pen drive, and when they have 1 GB of documentation, the microcontroller says boom. Now there's another FAT16 that there's in the SD, and it's isolated. So the person that you've paid for, you say, well, bring me that USB, and the person can't access the folders that you've stolen. It is okay, so it has cracked. So I have more empty mass storage. I will keep on using it, so you can do whatever you want. I'm going to show how the environment works. How long do I have? I want to show how the microcontroller would be used, so that you're not scared, because maybe this could be deterrent for some people. I have an Admiral programmer here, so in order to I've created a project. This is some kind of Visual Studio, but about microchips. I don't know if Microsoft has bought the Visual Studio, but this is a Visual Studio. In fact, it has plugins that are used in Visual Studio. So we can program a microcontroller as if it was a Windows program. We can go step by step. What I want to show it to you so that you see how easy it is if you're able to program in C. Here I have the full project, the SD Carmeyer. Here we are still in the blocks with all the logic behind. So everything that is done by the invention. Here, when a block is written, I say, okay, are they writing this LBA, that is a part of the mass storage? I say, okay. So when they write here, am I on stage number 1? If somebody writes the word DRG-Win, that is the name of this device, I say, okay, so I move to stage number 2. I'm in the machine that I want to attack, and I say to Arduino, please reboot it because I'm stage number 2. The Arduino reboots it, and when I'm at stage number 2, let's see what happens when it is read. Here we have the reading of the block. There's a reading, you have the LBA that Windows wants to read, give them whatever block. So when I'm at stage number 1, well, there's malware. The malware occupies some sectors. So I can say, well, I'm between these and these sector. Windows requests me for the reading. And if I'm at stage number 1, I'll give you this, the SB. And this addition, well, we have encoded malware, and it will be located here. It's like, well, I'm stage number 2, so I'll give you this executable file. So it makes the addition, and Windows says, well, give me what you have in sector 5. And depending on what stage I am at, I'll give you either one thing or another one. So the microcontroller takes it, decodes it, and it changes it. And here we have all the logic and well, everything. There's a C file, you can debug, prints, and so on and so forth. And you can purify it. This is really comfortable. So we're going to put a quick example. So for you to see it, if you want to, we are cleaning the microcontroller, okay? And this is how we program our microcontroller with AVR8. So you have the hardware and everything, all the interruptions, the USB, and we can go step by step. We've created the ward. Here I say, hey, Lifefrom has reset. So all the story I start the SD. Here I have the LEDs, and it's as if it was a Windows program that we are cleaning with Visual Studio. We can do anything we want. We have the flash here, we have the memory here, we have the accessible memory here. We can change different variables, local variables to put watches. Here we have integrated WAD. Here, for example, we have registries, so we can see how the microcontroller registries are, the data bear points. We have the I/O. That's very good. Well, I love it because you open here and you say, "Hey, this I/O, how are we doing?" I'm going to take it out from here. Here you can see the microcontroller ports. I want you to see them, so I double click here and I change them. I change the legs and what's going on. So we are interacting with what happens here. We have the counters microcontroller, we have the USARTs, we have the registries, we can see how EPROM is doing. We have many things here, and this would be the development. It's not very different to develop a C program in C, and this way it will be cleaned. The problem is that we can't clean in the middle of a USB. I can't be in the middle of a USB negotiation to include a black point and to expect Windows to wait for me. So we can put some prints and we can put some black points to see how something is, but that's it. We can't continue there, but I would be interested on knowing how these variables are working. I would reboost again in order to be at a different point, and I can clean. It's very difficult to clean USB. It's very difficult to diagnose bugs with the WebShark. You have that option to see all the frames, and with prints, with black points, with these type of things, you can see what's going on. And we always use other libraries. Please do not reinvent the wheel because it won't work. Okay, so some credits and some greets. Well, Gianni IRC Hispano, well, I didn't know a lot about electronics, and I'm really annoying him a lot, so thank you very much to Circular and Luis Fernando, who are my bosses at Panda. Jose Vicente Martinez, who is the person that has helped me manufacture the board. He's an electronic engineer and he deals with the manufacturing of miniature devices. So when choosing what small components I need for the board to be small, well, he's specialized in RF, in signal noise. And think about something: when we manufacture a USB board, you can do the data traces like cables. You need some layers, and you need somebody that understands about this. You can do a board and to make it work like this table. So this is a person that has helped me manufacture the board. If somebody wants to manufacture hardware and doesn't have a very good idea, I can put you in contact. So he's a very nice guy. He can help you do this. Of course, you have to tell you what you want, how you want it, and he will tell you, no, I'm going to put this watch because it's smaller. Let's use this thing here. We are going to have problems here. So this type of things, well, I have no idea about this because I have no idea about electronics. And Paul Stoffrichen, that is the one that has developed the TEMC ports, because this microcontroller is included in his board. So you have a Tensy code that you can see. You can program in Arduino or Tensy, so you have many libraries that can be used in Arduino to use a very similar controller to this. It's not the same, it's very similar. So if you want to program something here, you can have a look at Tensy and you say, okay, so this is done this way in this microcontroller, so I can use this idea. So you have a great community, and this is the idea. And Matthew Sonnet, who is the one who did the mass storage SD for that controller, the Lufa, that is the USB stack, and Chan, that is FAT, and Yasin, who is a colleague of mine that put me in contact with the electronic guy. So he told me, yeah, this guy is going to help you. And in avrfreaks.net, I'll open a couple of threads for these topics. So apart from this, so in rootkit.es, I'll put this board on sale when I know the real costs, and especially some other things are clear, because I wanted to change a couple of things that I don't like very much. But for you to have an idea, the board will be something like this. This antenna will be put inside. We are still thinking about these things. And what else? Well, and my GitHub, when the speech is over, I will upload the code and so on and so forth. And you have my Twitter address. And I don't know if you have any question. Now, when Abel is talking, I'll try to fix the reception. And if I have 5 minutes, I'll try to show how it works. And I don't know, questions, remarks, you can ask anything, okay? Any quick question? Yeah, there. I have some. There are no stupid questions, only stupid people. So, do you have any way to identify the operating system? Yeah, I haven't explained this. Yes, and the USB stacks of the different operating systems are a little bit different. Even SCSI to the mass storage, so it can detect whether you've plugged in the USB flash disk on a Linux or in a Windows, depending on how the protocols go. So this means that I can prepare a next and a FAD and put a malware. So I can infect Linux, Windows, and depending on where it is plugged in. I can do it, or I can have an idea about it. This gives problems. It's not a science that I would say always, but I've seen some differences. In fact, there are many bugs. When there's a mass storage, maybe it works in Windows, but in Linux, you say, wow, what happens? Maybe the USB in Linux is well done, and the USB is stuck in Windows. You need to know that you're going towards that. So I can do something like that. I can even the keyboard can say, hey, as a microcontroller knows, because of the USB negotiation, that I'm at a Linux, I know that I'm an Gnome or a KDE. So maybe I access to the NET and I can launch a malware. So depending on the negotiation, you could do different things. Yeah, but it's not as easy as you think. In fact, I forgot this. Something interesting is that in the case of Windows, analyzing the ASCII code, you can directly access the character you want. In the case of Windhoek, I think it's Control Shift, and the Unicode control. The Unicode code, sorry. Yeah, but I'm a little bit lazy. I prefer to have the codecs because I only need 2 points and the counter slash. So if you want to do it in a cool way, you can do it. Thank you. I don't know how were the questions or what was the. I don't want to take time for a bell. No, we're fine. No, we have lunch later. These people aren't hungry. So, raise up your hands, please. I think you were the first one. Yeah, please. You get started, and we'll hand over the mic. We can't see it all. Hello, hello, hello. Well, it's a remark. I was trying to listen to everything you were sending through 433, and I couldn't. So maybe the problem was the transmission. I have thousands of cables here. Yeah, it's a great mess. And I saw that there was a lot of noise in 433, so maybe there were more things calling you unintentionally. Yeah, I've tried this at home when there's nobody doing anything, but maybe here there are people doing things with their hacking networks, and the demo wouldn't work. Yeah, Raul was saying, well, out of everything that I've explained, to send things through the RF to Arduino was the easiest thing. I think that well, I know how to do this, of course, but everything that goes through the air is encoded. Okay, so you can catch whatever you want because you won't see anything. That's a challenge, mate. And the other questions here. It was me who made an interference. Oh, so it was you. So if all hackers are ethical people, so how can't we be non-ethical? So we are surgeons, we're not stabbers. There is no ethical surgeon. The surgeon, and hacker is a hacker, and stabbers are criminals. Ethical stabber, that would be good. When I hear ethical hacker, I hear ethical stabber. In social engineering, I've been able that they install a transmitter 433, and they connect it to the mic. So that's your interference. You've chosen frequency. Yeah, it costed $3. But well, this is a fun fact. It's people usually transmit through that radio frequency. It's a frequency for radio hams. So yeah, I will do several boards. You go and buy, and you say, well, I want it with 2.4. Yeah, just a minute. I think that Bud Strikes want to get into the discussion. I'm equal fun. So ICM, it's an I201 region. So the radio hand that you're speaking about has to be 432. That is just before. 433 is reduced power usage. So the band that I'm saying is from 430 to 440, but it's a shared use. So theoretically, we need to respect it, but theoretically. So this is conceit for a criminal. I mean, so this will screw criminals up. You know, people are free. I mean, you know, we are taking time from a bell. Thank you very much. Thank you. Very quick question. When you have it plugged in, you start emitting when you think that you have to filter. But if somebody is scanning bugs because of temperature, radio emission, or whatever, I would say that there's a radio frequency, and that's it. But a professional that, for example, well, a professional knows what he's looking for. Could you activate it through an external event? For example, could you wait for it to happen? Yeah, this is why I wanted to include a transceiver, because it can receive. So I can instrumentalize it from the external module that would be embedded in a registry case. I would be able to send an RF, and I would tell, hey mate, now we're filtering. And something very quickly, when you have the capital letters block, the shift block, I get it, because the driver updates and the driver says, now capital letters are activated. As it is a keyboard, Windows has to inform you. So that's the point. So the malware can communicate with the micro controller, activating and deactivating the shift tab. So this is what I can do, because Windows is bi-directional. Next year you have to deliver the extended version of this. This is what I've been able to do in a couple of months, and as I have to work, I didn't have much time. So we will finance. We'll fund it. We'll fund it. Yeah, money. Okay, thank you very much, David. So Abel, the floor is yours.